Hi there, welcome back again. If you are watching this video, you are probably interested with our paying course, Introduction to Computational Thinking. Now, suppose that you have already created an account on Tangnest STEM Academy for your child, and that he or she already has access to our free course. If that is not the case, please check out our YouTube channel and watch the video about how to create an account on Tangnest STEM Academy. I know many of parents have this important question, right? What will my child actually be studying if I buy this course? Ndabizi nta muntu utabyibaza. So let's start with the course name, Introduction to Computational Thinking. And when you look at it closely, there is this fancy word that many people don't even really understand. Computational thinking. So the question becomes, what exactly is computational thinking? And why is it important for children? Let me use this diagram to explain computational thinking. Computational thinking is a way of structuring problems so they can be solved step by step. It is a system of thinking habit. And on this diagram, you can see 5 thinking habits. We call them habits because computational thinking is not something kids learn once, like a fact or a concept or a formula. It is something they practice repeatedly until it becomes natural. And that's exactly what a habit is. So let me give you a simple example. Kids don't memorize decomposition, right? They develop the habit of taking a big problem and breaking that problem into parts. So the more they do it, the more it's become skills naturally. Now let's start with the first thinking habit, decomposition. Decomposition means breaking a big problem into smaller parts. Instead of feeling overwhelmed, kids learn to say, let me solve one piece at a time. Reka dufate urugero nko muri course yacu. Let's say a kid has a project to create an animation project or a game. So that's the problem kids should resolve. Now, the kids will practice the thinking behavior of taking that big problem and breaking it into smaller parts and start resolving one piece at a time. When he finished the first piece, then he go on the second, he go on the third, and so on. That is the composition. The second thinking habit is pattern recognition. Kids learn to notice similarities and repetition. So they begin to ask themselves, have I seen this before? And when they do that, something powerful happens. They begin to reuse solution and learn faster. So let me give you an example. In our course, when kids is writing code using the block-based coding, ashobora kubona one same block is repeating again and again. Now he can notice that repetition and use a loop instead of writing that one block 7 times. Then he can put in one loop. So that is um, pattern recognition, thinking behavior in action. The next thinking habit is algorithmic thinking. Algorithmic thinking is the ability to create a clear step-by-step instruction to solve something or to solve a problem. Kids, when they practice this thinking habit or behavior, they start think like this. First, I do this, then I do that. And when you look at it, this is exactly how complex systems and technologies are built. So let me give you an example in the Scratch project of algorithmic thinking. Making a character move through a clear step. Let's say the character is moving from point A to point B, and the kids is writing a clear instruction of how that character will move. That is algorithmic thinking. Now, the fourth thinking habit is abstraction. So, kids learn to ignore what does not matter and focus only on what is important. They develop this thinking behavior of identifying the key information and ignore the rest. So that is the fourth thinking behavior. Finally, the fifth thinking habit is logical reasoning. Kids learn to explain why a solution works. Instead of guessing, they learn to identify what caused the results. The cause-effect concept. So when kids practice this thinking behavior, they understand that every output depends on input. Those are the 5 thinking habits of computational thinking. And when kids practice those thinking habits regularly, something very important happens. They begin to develop better problem solving skills, clear decision making skills, stronger confidence when facing challenge, growth mindset. Those are thinking skills, not just technical skills. And the most important part is this: those skills apply to every subject and to every future career. And that's why computational thinking is very, very important for kids. Now that you understand computational thinking and you know what your child will be studying if you buy this course, an interesting question naturally appears. Why now? Why is it urgent? Let me use another diagram to explain this to you. According to neuroscientists, when kids are between the ages of 6 and 12, their neural pathways related to logic, sequence, and abstraction are highly plastic. And when neuroscientists say the brain is plastic, they mean something very important. They mean the brain can build a new connection when practice something. So, what kids practice repeatedly during this stage often becomes their default way of thinking later in life. This is the right window where thinking systems are built for children. And now, as a parent, you have 2 options. The first option, early training in structured thinking. If you choose this one, Here, your kid practices repeatedly, and through that repeated practice, the brain builds strong pathways. Over time, structured thinking becomes their natural way of solving a problem. So here is the second option. Either you choose the first one or you choose the second one. The second option, kids do not train this type of thinking at all. In that case, the child often relies on intuition and guessing. And the guessing may work in a raw complexity environment, but it normally fails when problems become complex. And we all know that the future is becoming more and more complex. So, as a parent, you have to choose wisely. So now that you understand what computational thinking is, you can enroll your kids in our course, Introduction to Computational Thinking, where your kids will begin building the thinking system that helps him to solve problems step by step. So this is our course. We have 6 guided projects and 2 self-made projects. And at the end of the course, your kids will get a certificate, and it's only 118. We have discounts, and we are only looking for 50 learners. Nitumara kugeza 50 learners, we will cross. And if you want to know more about how learning happens, watch the next video where we'll get to know how this learning happen, the learning loop, and how long this course will take. Thank you, kandi Imana ibahe umugisha.